Hello, students. Today we're talking about graphing functions, and we only have two problems that we're going to look at, and we're going to graph them by hand. So we're going to take a look at what this thing looks like. All right, so we have a function. We don't really know what it represents. It's just an abstract quantity. But we know that if we put things in, things are going to come out. So if we put numbers in for x, that will tell us what comes out of the function. We also know that there's an infinite number of answers. So we want to see what those look like on a graph. So we're going to approach this the way we did last time, which is to make a table. One thing you notice that makes this one a little bit more challenging is that there's a fraction in it. So we're going to be really strategic. Instead of just going 0, 1, 2, 3, 4, we're going to go, we're going to put in numbers for the domain. We're going to choose x's that make doing half of x easy. So this is going to be f of x. Okay, and then whatever comes out of here is going to be what our y value is. Okay, because f of x and y are a little bit interchangeable. Okay, so what's a number that's easy to take half of? Yeah, even numbers, like the number 2. So if I take half times 2, that's another way to say that is half of 2, and then I subtract 1, that is going to be kind of a cool point. Half of 2 is 1. 1 minus 1 is 0. So when x is 2, 0 is the result of this function. 0 is what comes out. And what's another easy number to take half of? Yeah, 4. What's half of 4? Half of 4 is 2. What's 2 minus 1? 1. Okay, it's also a good idea to try negative numbers. So what's a nice even negative number? Did you know negative numbers could be even? Yeah. How about negative 2? That's an even number. So we have half of negative 2, and then we're going to take away 1. Half of negative 2, if you have 2 negatives and you take half of them, now you have 1 negative. And 1 negative minus 1. Negative 1 minus 1 is negative 2. All right. What do we always like to put into functions? Good. We like to know what's happening at 0. So half of 0, that's not hard. Half of nothing is nothing, so half of 0 is 0. What about 0 minus 1? Yeah, minus 1 or negative 1. Okay, so now we have a bunch of inputs. We chose even numbers because taking half of even numbers is nice. So we kind of limited our domain by choice to even numbers. And then we saw what comes out. And we know that this represents an ordered pair. So 2 goes into the function and 0 comes out. That happens to be special because 0 comes out. You'll see where that is. In function notation, we could write it like this. 2 went in and 0 came out. Both of those you should be kind of familiar with. How could we write this one in function notation? We could say, when we put 4 into the function, 1 came out. That represents the point 4 for x and 1 for y. Okay, let's take a look at what these look like. When you have, before you graph, it's a good idea to sort of plan ahead. So where am I going to put my x-axis? Where am I going to put my y-axis? Sometimes we just put it right in the middle, and sometimes we kind of decide to put the x or y-axis higher or more to the left. This one looks pretty centrally located to me, so I'm just going to draw a regular sort of coordinate plane. I'm going to label my axes x and y. I could also label this f of x, but I think I'll name my line f of x. Okay, and then we can put these points on here. So 2, 0. Is that here or is that here? Well, the first number is 2, and that's my x coordinate. So I'm going to go 1, 2. Okay. My second number is 0. That's my y coordinate. So that means I'm going to go 0 on this line. And that means the answer for this point is right here. This is the point 2, 0. That's kind of special. It's the x-intercept because it's where y is 0. So wherever this thing is, it's going to cross through the x-axis at this point. That's the x-intercept. Okay, then we have a point 4, 1. That 4 is for the x, so 1, 2, 3, 4 is right here. Okay, and then I have a y that is 1. This is the y line, here's y1. So if I want to know where this point 4, 1 is, I have 1 for the y and 4 for the x, so the point is right here. Okay, we got some more points here. If -2 goes into the function, -2 comes out. That's kind of cool. And both are -2. The point is -2, -2. So for this one, I have to go to -2 on the x-axis, which is here. And I have to go to -2 on the y-axis. It's a little tight in here. Okay, this graph paper is very small. So there's -2 for the x and there's -2 for the y. So the point is right here where they're both -2. It's -2 that way and -2 that way. All right, looking good. Ooh, we have one more. We have the y-intercept because this is where x equals 0. This is the y-intercept. When we put 0 into the function, we get -1 out. So that's the point 0, -1. And where is that? Well, the x coordinate is 0, so I'm going to be right here. And the y coordinate is -1. So I have to look on the y line and find -1, which is right there. So it's this point right here. Now, if you accidentally put it over here because you got kind of mixed up, this point would not be in the line. So you would think, oh, maybe I graphed that one in the wrong place. It's really common for students to kind of get mixed up with the 0. So 0, -1 is what we call the y-intercept, and it is down 1 on the y-axis. Okay, it looks pretty good. We could have put 1 into the function. We could have put 3 into the function. We would get these points right here. It's a good idea to draw arrows on both ends. And I'm going to label this line. This line is f of x. Okay. Some teachers like you to actually write the whole equation next to it, so maybe I'll do that. So this is the line f of x equals 1/2 x minus 1. That's what it looks like. That represents all of the answers, all the points you could ever think of, all the solutions to this function. Okay, let's do one more. Here is a function called g of x, and we want to see what this thing looks like. So this one's kind of interesting. We don't have a number. Usually, you know, I think a lot of you remember something called y equals mx plus b, maybe from Math 7 or Math 8. Okay, this one's kind of weird, can be confusing because there's not a number in front of the variable. There's no coefficient, but there actually is. The coefficient in front is -1. So let's see how this would work. This one, we don't have a fraction, so we don't really have to think about limiting the domain. We can put in whatever we want. I'm going to start with something easy like 1. This is our choice. We get to decide what to put into the function. Okay, there's no right or wrong answer here. I usually choose numbers that aren't too big or aren't too small so I can get a picture of what the graph is going to look like. I'm not going to put in 3,000 even though I could because I don't want to graph x equals 3,000. That's not going to be on this paper. So let's do 1. And what am I trying to do here? I am trying to, okay, I'm putting that into the function g of x. Putting 1 into the function g of x. So this is why it's really important, you guys, to use parentheses when we substitute. Okay, so the minus sign or the negative is in this problem, and the x we're changing into a 1. And then we have the minus 3 at the end. Okay, so this says the opposite of 1, or it says negative 1 times 1. Okay, this is negative 1. Okay, and negative 1 minus 3 is negative 4. So I kind of see this as the workspace, and then this is the value of the function. So negative 4 comes out. When we put 1 into the function, negative 4 comes out. Okay, this is the one that trips people up. What if I put a negative into the function? What if I put negative 2 into the function? Okay, this is not negative 2. Okay, some people see the negative here and they think, oh, it's just going to be negative 2 minus 3. But that's not right. Because we're putting negative 2 into the function where x is, we have the minus sign or the negative from the problem, and we have the negative from the number that we're putting into the function. So this is really important to be careful here. This doesn't say negative negative 2. I mean, it kind of does. It's the opposite of negative 2, or it's negative 1 times negative 2. And if you've studied math a little bit, you know when we're multiplying a negative with another negative, we get a positive. So this is positive 2. Okay, that makes sense. What's the opposite of negative 2? Positive 2. Okay, now we have positive 2 minus 3. This is where your integer work is really important. 2 minus 3. 2 minus 2 is 0, so 2 minus 3 gets you back to negative, gets you all the way to the left to negative 1. Okay, let's keep going. What should we always put in? 0. Okay, what's the opposite of 0? Minus 3. The opposite of 0 is 0. It's the one number when you take the opposite, it doesn't change the number. Okay. And 0 take away 3. Don't say 3. Don't say 0. It's minus 3 or negative 3. If you're at 0 on a number line, joop, 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 and you go 3 left, you're going to be at negative 3. All right, let's do one more negative just to practice. So what do you guys want to do? How about negative 5? That'll be fun. Okay. Now, we can choose anything. I didn't say negative 400 because I don't want to graph that. Negative 5, though, I think I can graph. So we have the opposite of what? This says the opposite of x minus 3. So the opposite of negative 5 and then minus 3. Well, that's going to be the opposite of negative 5 is positive 5. 5 minus 3 is just 2. Okay, so that's it. Those are our points. Notice this time a lot of negatives and small numbers are coming out. So when I set up my graph this time, I'm going to put my x-axis a little bit higher. So you want to plan ahead when you draw your coordinate plane, especially when you're doing this by hand. So I'm going to put my x-axis a little higher. Just a strategy. When you do these a lot, you kind of find some things that work here. Remember, these are my y values. So I have 1 for x and negative 4 for y. Okay, so where is 1 for x and negative 4 for y? That's right here. 1 for the x value, negative 4 for the y value. It's going to be right here. Okay, I also have negative 2 and negative 1. So the first number is your x coordinate. I could write this in function form. We put negative 2 into the function and negative 1 came out. -2 went in, -1 came out. So that's that point right there. The x value was -2, the y value was -1, and there's the point. Okay, ooh, 0, -3. Where is that going to be? That is a special point. Our x value is 0. That means that's the y-intercept. Okay, the y number is -3. So I'm going to look on the y-axis and I'm going to find -3. And there it is, right there. Oh, I covered up the -3. My goodness. Okay, that says -3. That is a special point. That's my y-intercept. That's where the line is crossing the y-axis. Okay, and last one, we have -5 for x. We can find that, -1, -2, -3, -4, -5 is going to be right here. -5 for x. And what do we have for y? 2. That's going to be up here. 1, 2. 2 on the y line is right there. So I can go or and that's the point right there. Do they all line up? Woohoo! That's a good thing. If one is not in line, either you screwed up something on your table or you screwed something up from the table to the graph, which happens. You just want to find the point that's not lining up and fix it. And it's also a really good idea to check these with Desmos when you're done, because we don't want you to practice bad. Okay. I think Mr. Pagali said, perfect practice makes perfect, or yeah, practice becomes permanent. So don't do these wrong. If you're unsure, stop what you're doing and go check in on Desmos before you continue. Okay, this is about paying attention to detail. This is about being careful. This is the type of thinking we ask you to do in an algebra class that helps your brain focus on details. Some kids get confused when there's a fraction in the problem. An algebra student can think about what domain can give functions whole number outputs. And, in math, we can use the numbers to think about what shape would be created. Be good, work hard, keep learning. Bye.